Welcome back, guys. It's been a while, but we are getting back with another video. Today we compare performance of three databases as said in the title, so let's go. What we are about to do. So first and foremost, this video builds on the article that I have written where I compared MySQL and Postgres performance on my local machine, and today we will do this remotely and have MariaDB as well. So what we need to have to do this? I have prepared lots of scripts, but we do need to have Docker, Bash and Python, and if you also want to run it remotely, as we will in this video, you do need to have DigitalOcean account. But before jumping into the instructions and running specific test cases, let's draw some context what we have. So three databases and a few tables. Since we do have lots of test cases, 17 in fact, and we have 4 tables. User, as you can see, order, what's important, order has a foreign key to user, and there will be many to one relationship, meaning that the user can have many orders, and order can also have many items joined by this order item association table. So we have all kinds of relations to test. We have a few indexes, as you can see. And we test both joins, thanks to having those type of relationships, as well as with deletes. You can see that we have on delete cascade type foreign key, so it will impact on this performance, obviously. And to run tests, we have this single Java 25 file. Let's maybe go there for a while. So here it is. It's just a single Java script, Java file script, not JavaScript, written in Java, and it allows to run various test cases. Basically, nothing special here. Virtual threads for performance. Maybe what's more important is that we have configurable connection pool here to be of slightly different size depending whether it's MySQL, Postgres or MariaDB, and we have 17 use cases, test cases handled there as well. Yeah, it's in Java 25 and Maven, but we built in Docker, so we don't need to have that. 17 test cases as said. So let's start, guys. So first and foremost, we need to have machines on the DigitalOcean infrastructure. So let's just follow along with the readme. In Python environment, we just need to have requests here, I believe, dependency, basically to make HTTP requests to DigitalOcean API and set up the infrastructure. One more thing, you need to have your API key for DigitalOcean and SSH key fingerprint, because we have 6 machines. I think I didn't tell that. We have 6 machines 3-4 databases. Each database will have its own, and each test runner, let's say, will be also having its own, because for every database we have a tests instance, and each of them, they will have 8 CPUs and 16 gigabytes of RAM. So maybe before starting those machines, let's take a look on Postgres customization. So besides user, obviously, what's important here is that in Postgres I customized all databases a bit, so you can see increased shared buffers, work mem, and effective cache size for Postgres. I made slightly different customizations for MySQL and MariaDB, obviously. For more important things, I changed the transaction isolation level for MariaDB and MySQL, because that's the default for Postgres, and for MariaDB and MySQL they have repeatable read, which could impact performance. So I just wanted to make it clear. And again, if you want more details, read my blog post. I dig deeper into those config options there. But yeah, getting back to setting our infrastructure. So you need to have these two variables. SSH key fingerprint is crucially needed to access the machines, the virtual machines that we're about to create. So I have done it already. So I have my API key here, and I should have my SSH key fingerprint. So right now I can just run the prepare infra script, and that will take a while. As you can see, we are creating I didn't expect that, guys. The droplets of this size will not be available in my region of choice, so let's change it to New York and see. Yeah, one more bug and we should be good to go. Yeah, so yeah, let's ignore that. I changed the regions, and as you can see, the droplets virtual machines were created. We can go to my DigitalOcean account and see we have nice beefy 6 machines for each for the database, each for one database, and each for one tests instance in New York. And yeah, so let's go to the README and proceed. So we need to build databases in Docker, obviously. For me, it's faster because I have already done that. And if you do it for the first time, it downloads a few base images from the internet, so it might take a while. And also, if you are curious what we are doing and here and how we are about to deploy it, we are following the pattern that I have presented on a few videos already, where we are saving the Docker images into the tar archive and then loading them on the target machine. Yeah, so with that being said, let's wait for the DBs. So we have our databases. We need to grab a few IP addresses, as you can see. So the first one is for MySQL. So let's take it's a public IP address, and then we have one for Postgres. Let's grab that, and then the last one for MariaDB. It's all done to basically deploy the three databases that we have built in the previous steps. So let's deploy DBs. And what we are doing here is using SSH to send build in the previous step Docker images and load them onto these three machines. And this might take a while, since the images, they are a few hundred megabytes. Yeah, but in the meantime, we can set up, as it's progressing, let's go to the terminal, and we need to have a few windows here, a few terminals. So everywhere we have an ops user, let's grab, let's go to all machines basically. So first we go to the MySQL. Yeah, let's see whether there's something running. Oh, we have MySQL running already, so it means that it was deployed. But let's log here to MySQL as well machine, and let's do let's have it, let's go to the database. I think we need to do something like that. We have performance database. Yeah, not MySQL, but MySQL performance. And yes, MySQL. Its password is performance. And let's see tables. We have them. So right now let's do the same for Postgres. So let's SSH there. Let's see stats. Yeah, we have running database, Postgres, and let's SSH there again. And similarly, let's go to the database. I think it was something like that. Different syntax. Yeah, so we have it. And lastly, MariaDB. Oh, still not deployed. Okay. Let's see. Alright, something went wrong, guys. What have I done? MariaDB host. Yeah. So not good, guys. I have exported the wrong host. So let's go to deploy MariaDB once more. So what I will do is I will comment this out and deploy only MariaDB. Yeah. Let it continue and let's go back to our terminals. So we have MySQL, we have Postgres here as well. Here we don't have MariaDB yet, but we will soon have it. So let's get it there. In any case, this should, yeah, we should already have that. We have, let me uncomment that in case I forgot to do so. And similarly as with, it's almost the same as for MySQL, since MariaDB is just a fork of it. But here we will change that and change this guy. Yeah, and here we have, guys, so 6 terminals for 3 databases. Yeah, and we already validated that we have databases, so right now let's speed and package our tests. Similarly as with databases, this can take a while. If you are doing it for the first time, you need to have 2 base images here for Java 25 and Maven. Alright, and right now we will deploy this guy to 3 machines. Because for each database we have dedicated tests machine. So for MySQL we have this, for Postgres we have this guy, and for MariaDB we have this guy. I think that's correct. Let me check. Yeah, and let's deploy tests. Yeah, and here it will go again to 3 machines, and it will also deploy this run test that will allow us to choose a particular test case to be run. But in the meantime, as it progresses, we also can go to these guys, SSH into them, yeah. Yeah, MySQL tests, and here we should go to tests, and yeah, and from this directory we will run tests for MySQL. Let's do the same for the for Postgres. As you can see, we have lots and lots of terminals should be here. Yes, we have it. And the last one is for MariaDB. So let's SSH there as well. Deploy tests, and we should have it. Let's clear it. 9 terminals. MySQL stats, MySQL DB, Postgres stats, Postgres DB, Maria stats, MariaDB, MySQL tests, Postgres tests, MariaDB tests. Nice, guys. We have everything prepared to run tests finally. So let's go. 17 test cases. Let's start with inserting users. One more thing. We need to export the VP host, and what's different in this case is this IP is that we use private one to communicate in the private network, having lower latency. Postgres has this SQL. Let's do Postgres here, and MariaDB has 7 at the end. Right. Alright, guys. Now I think we are ready. Insert users, MySQL. And here similarly insert users, Postgres running, so we are connected. That's great. Insert users, MariaDB, and we are connected as well. Let's see the CPUs or databases. They are working MySQL a lot. Guys, so in general, most of the test cases, I designed them to take about 10 seconds, meaning that they have certain queries rate and they repeat it 10 times. With users, I think they have 20. So MySQL has finished. As you can see, we wanted to have 10,000 queries per second. It almost did it. Same with Postgres. So they are all similar, but the test script is designed in a way that it has some delays, so they probably still have something left in the tank. So what we are going to do, let's double the rate. So we had 10,000 by default. Let's do 20,000. Let's repeat it here as well, and see what they have left. So again, insert users, MySQL, but double the rate. Same here, but Postgres. And same here, but MariaDB. and yeah, we see what they have left in the store. Let's see the CPU. Yeah, we have 8. So they are, yeah, Postgres has finished probably. Yeah, so as you can see, Postgres, amazing performance, cost to 20,000. Same for MariaDB, and worse for MySQL. Yeah, so MySQL is worse, as you can see. Similar for Postgres and MariaDB, and probably we can bump it, maybe, but for Postgres and Maria. But let's go with two different test cases. Unsetting the queries rate, right? To have the default for the next test case, and our next test case is inserting items in batches. So let's do that. Same with here, but with Postgres, and same here, but with MariaDB. Yeah, and what we are doing here, we are running just 500 queries per second, but it's a batch insert of 100 items, so 50,000 per second items are inserted, but in batches. Yeah, it's finishing, I believe. Yeah, so well below the wanted queries rate for MySQL, as you can see. Same for Postgres and same for Maria, but as you can see, they are pretty close. Yeah, pretty close. Yeah, so let's not rerun the case. Maybe let's look at the percentiles. So MySQL was the best here, as you can see, looking at latency at 99th percentile. Yeah, or MariaDB. Yeah, but they were very close when it comes to throughput, which is the most important. Oh, I mean, latency is also important, but not with that type of difference. So let's go to another insert. We have orders in batches. Let's see what they have here. Postgres and MariaDB. Yeah, so also batches of 100, but a different table. So MySQL has finished below expectations, but over 1,000 batches per second. As you can see, it's also an order of magnitude more than with items. With items, we basically have different schema, and it has quite a bit of impact. So Postgres is definitely better here, and MariaDB slightly worse than MySQL, but they were all below expectations. So again, let's not rerun, but I think it's clear that Postgres did the best here, and MariaDB and MySQL were closer to each other. So let's run the last insert case, which is order items. So basically we're connecting the previously inserted orders with previously inserted items. So MySQL Postgres and MariaDB. Yeah, order item. In the meantime, as you can see, we have 128 connections and 64 for Postgres and 128 for MariaDB as well. It's just something that I have experimented with, and it's just that Postgres performs better with slightly less connections than MariaDB and MySQL. Yeah, it also will take a little longer because to insert order items, we need to get order IDs and item IDs from the database, and it's done in the meantime. And I exclude it from results, but it does add to the tests time. Alright, MySQL has finished. As you can see, pretty close to expectations. Interestingly, Postgres did slightly worse. And same with MariaDB. So here MySQL seems to be running the show. Yeah, interesting. Yeah, interesting. So batch inserts are pretty mixed. Let me just check one more thing. Yeah, we have results here, and we will create a nice summary afterwards. But yeah, let's go to selects, guys. So we have select users by ID. We have 1 million users at this point. So let's run it for all DBs. Yeah, as you can see, we have users count. Let's see what the databases are doing. Too late. As you can see, also the memory usage for MySQL was 3 GB, so it's using set up cache in memory. Alright, so MySQL 22,000, way less than expected. 34,000 for Postgres, and best for MariaDB. Interesting. Win for MariaDB. Yeah, but MySQL is significantly worse. Let's go to another select, which is select users by email, and they have index on email. What's different is that it's a secondary index for MySQL and MariaDB, and for Postgres it doesn't matter basically because of its architecture. So let's run it for 3 databases. Yeah, same table. Yes, pretty loaded. Alright, let's start with MySQL again. Similarly to slightly worse than by IT. Postgres, and again MariaDB has one. Nice. Yeah, and MySQL is significantly worse here. You can see Postgres and Maria did similarly. MariaDB has better throughput. Latency is slightly better for Postgres. So let's go to the next select, which is slightly different. Here we will select pages sorted by ID. So multiple rows and sort. So MySQL again. Postgres and MariaDB. Let's see, same table. Yeah, so we wanted to have 5,000 queries per second. So you can also see how much worse that is. The same table than selecting single rows by ID. We had over 20,000 queries per second then. Now it's almost another magnitude worse. But still, it's a few thousand. Postgres slightly better, but as you can see, it's pretty close. And MariaDB has it the best. I think for MariaDB, let's try to increase it out of curiosity to, I don't know, 7,500. It was set, right? Yeah, let's run it with this query rate. Maybe to handle it, maybe not, but yeah, Postgres similar to MySQL, but better latency. As you can see, 82 milliseconds for MySQL at the 99th percentile, almost half for Postgres. Yeah, it did worse, but yeah. So that's the limit for MariaDB, but clearly the best for this particular test case. Yeah, guys, so let's go with the next test case, which is joins. So we select orders joined with users. So again, MySQL, Postgres and MariaDB. Yeah, here we want to have 35,000 queries per second. As you can see, we have 1 million users and 2 million orders. So let's start with MySQL. So MySQL didn't make it, but still lots of queries. As you can see, with one join, 20,000 over 20,000 per second. Similar with Postgres, slightly better to MySQL, but close. And MariaDB, significantly better. Interesting. Yeah, so close performance for MySQL and Postgres, and win for MariaDB for first joins case. Let's go to next case. We have another join. It's orders joined with items, but what's different here is that there are two joins. Orders to order to order item, and then to item. So again, MySQL, Postgres, and Maria. And as you can see, we are dealing with three tables 4 million order items and 2 million orders. So we have on average two items per order, and 17,000 queries per second for MySQL, below expectations, similar for Postgres, and again the best with MariaDB. So MariaDB is the best of joins, it seems. Right, so then we have a last select case. It's also with joins, but it joins users with orders, but calculating some stats, which is aggregate functions. So let's see how DBs perform there. Postgres and MariaDB. Let me plug myself to the. Alright, so for MySQL, below expectations, 18,000. We wanted to have 40. Same for Postgres, but better. And again, the best for MariaDB, but pretty close. MySQL definitely has to lose this battle. So let's go to updates, guys. First, very simple, updating user image by ID. Images are indexed, an indexed field. That's important to keep in mind. So MySQL, Postgres, and MariaDB. Yeah, it can be slightly slower because we are selecting users by ID. We are selecting user IDs before updating their image by ID. So it takes a lot of time, as you can see for MySQL. For Postgres has finished. We wanted to have 5,000 updates. As you can see, it's nothing. For Postgres, same for MariaDB, and for whatever reason the MySQL is running slowly here, very slowly. It's strange. So as it's running, let's pump queries rate for Postgres and MariaDB, since it was this rate was nothing for them. And let's run the case 11, Postgres and MariaDB. Yeah, again, nothing for Postgres and nothing for MariaDB. I don't know. So while MySQL is sleeping, let's actually bump it even further to 20,000. But here let's also increase this guy because we want to have a few rounds of queries. So with this rate we would only have 2, and if we bump queries rate to 20,000, there's a queries rate to 200,000, this will give us 10 rounds of queries. So let's do the same here. Let's 0 and queries to execute, and let's run the test 11 Postgres and MariaDB. Yeah, so it's running again. Amazing performance. As you can see, guys, something weird has happened to my SQL, because like we are 20,000 almost with Postgres, and it seems that MariaDB can make even more. Let's try to do 30,000 for both MariaDB and Postgres. Queries rate. And we will fix the MySQL because we still don't know what it can handle. Alright, so running test case with, yeah, so that's the limit for MariaDB, and yeah, so close to 20,000. I don't know what happened with MySQL, so let's restart it basically. So stop it, and let's start it. Yeah, and let's try to run this test case for MySQL. Maybe right now it will work. Yeah, it will. Suspicious, guys, suspicious. We need to restart it for it to be functional, basically. But good performance, as you can see. So similarly, let's increase it to 10,000 and see whether it can handle it. Yeah, not 10,000, but yeah, 7. So significantly worse, as you can see, compared to Postgres and MariaDB. So let's unset queries rate, queries to execute for Postgres and Maria, and let's go. Then we go to next test cases. We still have a few of them. Yeah, let's unset this. And next we have updated ads. What's different? They are not indexed. So in theory, performance should be better for updates. Yeah, number 12. Yeah, so MySQL has finished. Yeah, they will be all below. Yeah, so knowing what happened in the last case here for MySQL, let's bump it to 10,000. For MariaDB and Postgres, let's bump it to 20,000. We know that they will be able to execute 10,000 with any problems, because this case can only be better for them. Than the previous one, since the column is not indexed. So yeah, let's run the 12. Number 12 once again. Postgres and MariaDB. Yeah, so yeah, and slightly better for MySQL than the previous case. It was almost 8,000. Here we have 8,000 and a half. Yeah, Postgres almost 20,000. Same for MariaDB. Yeah, so the last update case, we have update of multiple fields, the same table, but in practice it means that we are updating emails and updated ads. Let's unset our configuration here, and let's run test case number 13 out of 17 for MySQL for mistake. Yeah, Postgres and MariaDB. Yeah, so MySQL did it more or less. Obviously, same for Postgres and MariaDB. So let's do again queries rate 10,000. Queries rate queries to execute 200,000. Queries rate 20,000. Same here for MariaDB. And let's run it again, guys. 13 MySQL. Postgres. And MariaDB. Yeah, so similar to the first case, expectedly, since we are updating both indexed and unindexed column. Similar for Postgres, yeah. So significantly better updates performance, as you can see, for MariaDB and Postgres as compared to MySQL. So again, let's unset our customizations. Queries rates, and let's unset it also here, and let's run the next test case, which are deletes. So we will delete orders and they cascade to order items. Keep that in mind. So the test case number 14 for all databases. Yeah. Yeah, so we wanted to delete 10,000 orders per second. MySQL almost did it. Nothing for Postgres and nothing for MariaDB. So yeah, so let's leave MySQL as it is. And here, let's maybe do 25,000 to be honest, because it should be less costly than updates. That's why I wanted to bump it like that to 25,000 instead of 20. Yeah, so let's Postgres and let's MariaDB. Yeah, and as you can see, it was about close to 20,000 per second. Same for MariaDB, and slightly better. Yeah, slightly better. So let's again unset queries rate, and let's go to our another delete case. We will delete orders batches basically. And so let's test case number 15. We are close to finish, guys. MySQL, Postgres, and MariaDB. Yeah, so we are deleting orders in batches of 100, 1000 per second. So we are trying to delete 100,000 orders in seconds. Yeah, so MySQL didn't make it, but still times 100, this rate times 100 is quite a lot. More than enough for Postgres and more than enough for MariaDB. So we could rerun it for MariaDB and Postgres, but we would have too little orders. So what I am about to do here is let's unset. First let's no, we don't have it. We need to have more orders basically. So I will insert more orders so we basically rerun insert orders in batches for Postgres, and we rerun insert orders in batches for MariaDB, and then order items, so that we actually have enough orders. And since deleting of order cascades to order item, I would also like to have more order items. So let's rerun that for the sake of having more data, basically. Yeah, so let's insert order items in batches as well. Same here, insert order items in batches, and then we rerun the delete test case. If I remember, we wanted to delete with deleting orders in batches. We wanted to delete 100 orders in batches of 100. We tried to delete 1000 batches per second like that, but we got a lot above wanted rate performance, so I would double it basically. Yeah, so it finished. MariaDB is still running, so So let's wait. Let's wait for it, and then we will say queries rate 2000. Yeah, 2000, 20,000. Same here. And let's now repeat the delete orders in batches with this increased queries rate 15, and let's see. Yeah, even better, but let's stop there. Yeah, it's with MySQL it was 400 deletes, almost 500 deletes per second. As you can see, it's much better for Postgres, and let's check what it is for Maria. Yeah, it's worse than for Postgres, but still out. Alright guys, let's unset queries rate and let's go to the last two test cases, which are the penultimate one is inserting users and orders with items and transactions. So we have one transaction. In one transaction, we are inserting user, order, and two items. Actually, so let's run it. 16. Yeah, so MySQL has finished and it did more than needed, as you can see. All databases did. So it's not representative. Let's double the rate to 5,000 transactions per second. Remember, each transaction doing 4 inserts. Yeah, so 16 MySQL, 16 Postgres, and 16 MariaDB. Yeah, almost. MySQL also has almost done 5,000. Even better. Yeah. Actually, let's then repeat it with 700. Yeah, for MySQL, let's go with this rate. And for Postgres and Maria, I would like to try even higher rate, which is 10,000. Typo. Yeah, so let's set this up and queries to execute. Yeah, and let's maybe also do queries to execute here. Yeah, that's correct. Let's run it. Running it. Yeah. Postgres and MariaDB. Yeah, so it is a limit for MySQL. Previously, yeah, it did almost 5,000, slightly above. Yeah, almost 10,000 for Postgres. It's even better for MariaDB. So let's maybe rerun them for both Maria and Postgres with 15,000, which is a lot because every transaction it's doing 4 inserts. Remember that. So lots of inserts. MariaDB. Yeah, but even for MySQL, 5,000 over 5,000 queries per second times 4. So in total, it's more than 20,000 inserts per second. And if we go to insert users, where we have it. Oh yeah, we have this case. Yeah, we then did 11. So yeah, it's with transaction, it's doubled basically. Users with items, and the last one we had this. Yeah, so it's a limit for getting back for Postgres and MariaDB. Nice. It has to now 1500 per second. Nice. I mean 50,000. 1500. 50,000 almost 15,000 transactions per second with 4 inserts. Nice. So let's unset queries rate. Let's unset queries to execute. So here. And same here, and we will run the last test case, guys, which is inserting, updating, deleting, and setting users by ID. To give more context, we are doing this one-to-one write-read proportion, meaning for every insert, update, or delete, there are 3 selects. So a typical mixed workload. So let's see how databases are handling this particular use case, test case. Yeah, so MySQL almost did it. We've wanted 7,500 queries per second. Postgres did it, and yeah, way over from MariaDB. But let's give MySQL another chance with 10,000 queries rate. Yeah, with 10,000 for Postgres and MariaDB. Let's double that. Yeah, let's double that to 15,000. Let's run it, guys. Last case, MySQL. Last case Postgres, last case MariaDB. Yeah, so it's a limit for MySQL, but as you can see, close to 10,000, acceptable latency as well. Postgres almost did it with 15,000. And Maria still has something left in the tank, so nice with mixed workload. We can already see that MariaDB is winning, but let's give it another go with 20,000 queries rate and 200,000 queries to execute. And so let's see whether MariaDB can handle such a load. Seems that it can, which is pretty impressive. Yeah. Interesting. Let's give it even this amount, which is 30,000, sorry. Yeah, so much. And probably that will be the limit, but I don't know. Yeah, that was the limit, but yeah, as you can see, significantly better than Postgres and lots of better than MySQL. Maybe let's give Postgres a go with 20,000, but looking at previous results, it's probably will not be better than 14,000. With the wanted 15,000 case, but yeah, let's try and see. Maybe. Yeah, so it was better. Yeah, so let's maybe try what the MariaDB has done. So not 25, but 30,000. Let's try it with Postgres, and maybe to be fair, with MySQL, let's give it another shot. With 15,000 and see whether it can or not handle it. Yeah, so Postgres did better still, but I believe, yeah, worse than MariaDB, but yes, the difference is, as you can see right now, less. And yeah, so MySQL also did better with 12,000. Yeah, so let's maybe give it a go with 20 as well. Since it might have something in the tank. Yeah, because it's below, but not that much below, so maybe there's something left. Yeah, slightly, but yeah, so 12,000 per second for MySQL of mixed workload, over 20,000 for Postgres and MariaDB. Yeah, guys, so I think that's more or less it. That was a really comprehensive performance comparison. So here I will show you the summary, the results. Yeah, and that being said, if you want to dig into a little more details and how I did it locally and what the results were, because they were slightly different, I will link down below my related article. And in the meantime, if you like the video, subscribe to the channel, and I see you in the next one, guys. Cheers!